Class, today we're going to be doing section 1.5, and this is including solving quadratic equations. So what we need to do is first of all look at the definition of the quadratic equation. Okay, so notice that here we have this quadratic equation in general form. So notice that this is always going to be the general form of a quadratic equation. Notice that you have an a in front of the x squared, you have a b in front of the x, and then you have plus c to where it looks like there's no x there, okay? And it's always going to equal 0. So first and foremost, in actually solving these things, you need to understand that you have to know what a is, what b is, and what c is. And also know that it has to be in this form before you start actually solving for it, okay? So here, notice that they have constraints on this where they actually say that a cannot equal 0. Because if a were equal to 0, notice that all of this would be covered up and it would be a linear equation as opposed to a quadratic equation. Okay. So with that being said, this is called a second degree polynomial equation because the highest exponent is 2 in here. And so if you'll notice that our a in this particular example is going to be 1 because this is implied in front of that x squared. So remember all the implied things around variables or numbers. Okay, so a is going to equal to 1, and notice that in this b we've got this -7. So notice it includes the sign out in front. Okay. So remember that the sign always follows with it. And then, of course, we have c equals 10 on this. So this is just kind of getting acquainted to with, you should know what a is and what b is and what c is. Okay. All right, so as far as the zero product principle goes, this is a very nice principle here. It helps out with us knowing a couple of things about solutions for this, that sometimes you'll be given already particular examples that are already factored. In these following examples, notice that these equations are not factored yet. So I want you to know that if you are needing a skill builder in factoring, you need to go back to the prerequisite sections over there in My Labs Plus at the very beginning. Remember, they're labeled as P, and they're there for the whole entire semester, so you can do as many or as little as you need to in order to know what factoring is. Okay, and also if you need help factoring, please ask me or go get assistance at the tutoring center, or at least ask about it in class. Okay. So, of course, we're going to go over these examples with factoring, so maybe by that point you'll kind of recall what factoring is. If not, again, you have people, me, tutoring, and My Labs Plus to help you with that assistance in factoring. Okay, so what the zero product principle states is that if you have two factors, and remember factors are being multiplied together, terms are being added together. So notice that a and b here are two factors because they are being multiplied. Then this means that a equals 0 or b equals 0, because that would hold true. So notice that if you had a equaling 0 here, then 0 times b equals 0. So that would work. If you had b equals 0, if you plugged in a 0 for this b over here, notice you would have a times 0 equals 0. So that works as well. So what we're doing is that, in short, I want you to know that we're taking each factor and setting it equal to 0 and solving. Okay. So what this is saying is that you should set each factor equal to 0, then solve. So that's basically what you're doing with this. Okay. All right. So now getting into the factoring portion of it. Okay. So what I'm going to do on the right-hand side, way over here, is actually do a little bit of the scratch work and factoring. So I'm just going to label this as scratch. Okay. So in this, I know that in factoring, the best way to do this, the most procedural way to do this, and it works every single time, is using the AC method. So our AC method denotes our A, B, and C here. So AC, we're going to multiply the A and the C together. So we have 9 times 2 equals 18. Then we're going to look for factors of 18 that add together to be 9. So factors of 18 that add together to be 9 are 6 plus 3. So 6 times 3 is 18, 6 plus 3 is 9. So these are our magic numbers that we want to split that 9x up into. So we have 9x squared plus 6x plus 3x plus 2 equals 0. Okay, so from here, notice that I can go ahead and group the first two terms and then group the last two terms together. So I have 9x squared plus 6x, grouping those together, plus 3x plus 2 equals 0. So I've grouped my first two terms and my last two terms together. So out of this grouping here, notice I can go ahead and factor out a common factor. The common factor in here is a 3 and an x. So I can factor out a 3x, and what's left over from this is my 3x and plus 2. And notice this is already prime. We can't take anything out of there. None of these have a common factor in which we can take out. So we just simply put the implied portion here. So we have that 1, and we have the 3x plus 2 equals 0. So now notice that this is a term, and this is a term because there's a plus sign between those. So from this, notice that we have this 3x plus 2 within each term. So we're going to go ahead and factor that out. So we have the 3x plus 2 here. And what's left over is this 3x in that term. Whoops, not 3x, not 2x. 3x. And then my plus 1 over here in the second term. So now that we have this factored, we can now use our zero product principle, which states that I can say 3x plus 2 equals 0, or we've got 3x plus 1 equals 0. And so now notice that we have to solve for x. So when we solve for x, we simply move this 2 over, which creates a negative 2. So 3x equals minus 2. So this means that if I divide both sides by 3, I get negative 2/3. So here's one of my solutions. Another solution is that when I start solving for this equation, move the 1 over, so I have 3x equals negative 1. And so then when I divide both sides by 3, I have x equals negative 1/3. So here are my two solutions. And so what I did was I used the AC method for factoring. Notice I had them in 4 terms, grouped the first 2 terms together, then grouped the last 2 terms together. Notice that there is a plus sign, which is super important. So then from each grouping, I took out the common factor. And then from each term here, I took out the common factor, which was that grouping. So we always want those two to be the same. And then so now since I have this equation fully factored, I can go ahead and set each factor equal to 0 and solve for x. So what we're going to do here is that, remember, in the very, very beginning, we had this equation, right? General form, to where we had it equaling 0. So this means that in this particular equation down here, notice that we have to get it into general form first before we actually start to solve. So what we're going to do is we're going to take all of this stuff, and let me choose a different color so it won't bleed into the other problem. So we're taking all this stuff and moving it over to this side, which changes all of these signs in front, okay? So when I move it, I've got my x squared plus 11x plus 10 equals 0, okay? So again, using the AC method, our A in the scenario is 1, our C in the scenario is 10, so we have 1 times 10 is 10. Factors of 10 that add up to be 11 are 1 plus 10. And so that's what I'm going to use as my magic numbers to split this up into. So all I'm doing is taking this 11x and I'm saying that those get split up into x plus 10x. And all I have to do is bring down the x squared and bring down the 10. Group the first two and then the last two. Take out the common factor in each grouping. So the common factor here would be x. What would be left over is x plus 1. The common factor in this grouping is a positive 10. So now the leftovers are, again, x plus 1. Now looking at both of these terms, we see that there's a common factor of x plus 1 in there. So what I'm going to do is I'm going to go ahead and factor that out. So I have x plus 1, and the leftover is the x. Leftover here is the x, and then the plus 10 equals 0. So now that this is fully factored, I can go ahead and take this factor and then this factor and set them equal to 0. So I have x plus 1 equals 0, or x plus 10 equals 0. So this means that when I solve for x, my x is going to equal -1, or it's going to equal -10. So those are my two solutions. So notice that in the AC method, I still use this even though that this is 1. But note that the shortcut would be to not do all these steps. And notice that these two numbers here, if I multiply those together, then that's 10. If I add those together, then that's the 11. Okay? So basically, notice if you have a 1 in front of this x squared, you can go ahead and utilize that shortcut to where all you have to do is think of factors of positive 10 that add together to be 11, and you can put those on the left-hand side inside the parentheses. Sorry, on the right-hand side inside the parentheses. Okay? And again, we can discuss this more in class if you would like. Okay, so for this next one, notice this is not in general form yet. So first of all, if you'll notice that I need to go ahead and distribute the 16x through. So I have 16x squared minus 32x equals 8x minus, not 12, but 25. Erase that. Minus 25. And so, of course, I need to get it into general form, so I'm going to move everything over to the left-hand side, where the right-hand side is just 0. So I'm going to leave the 16x squared here. And if I take this 8x and move this over, then that means I'm going to have a negative 8x over there. So altogether, that would be negative 40x. And if I take this negative 25 and move it over there, then that means positive 25, and that equals 0. Okay, so AC method. So here I've got A times C, which is actually equal to 16 times 25, which is equal to 400. Okay, so now we have to think of factors of 400 that add together to be negative 40. Okay, so if you'll notice, there's a lot of factors of 400. Okay, so what we're going to do is we're going to look for these factors and be like, okay, well, we've got, first of all, 20 times 20 is 400, and 20 plus 20 is positive 40, but we want a negative 40 out of this. So we have negative 20 plus a negative 20 gives us negative 40. Okay, so these are two little magic numbers that we can split this negative 40x into. So we have 16x squared minus 20x minus 20x plus a 25 equals 0. So now this is really important. In order to group items together, like the first two and then the last two, a plus needs to be in between these. Okay, so I'm just going to put a plus there and circle it so that I know the grouping symbols go around that and not include that. Okay. All right, so with that, now that we have our plus and we have our grouping of the first two terms and then our last two terms, we can go ahead and take out a common factor in the first grouping, which would be a 4 and an x. And what we have left over is 4x minus 5. And then we have a plus there. And so what we want, though, is we want that this factor has to be over here, this 4x minus 5. Otherwise, we won't be able to factor it out at the end. But the only thing is here now is that we have to figure out what goes in front of that. Well, I know that something here times 4x is going to give me negative 20. And so I know that to be negative 5. Okay. So just checking myself, I've got negative 5 times 4x. That gives me the negative 20x. I have negative 5 times negative 5, which gives me the positive 25. Okay, so out of this first term and out of the second term, we've got this 4x minus 5 that we can factor out. So I'm just going to simply write this in parentheses. And then I'm going to write all the leftover stuff. And when I talk about the leftover stuff, it's this. So I got the 4x goes here. And then I have the negative 5. So minus 5 equals 0. And notice that you have these two factors here. So we can just say we don't have to write them down twice because otherwise you're just going to have x equals 5/4 and x equals 5/4. It wouldn't make any sense. So because we have these repeating solutions, just write it once and that will suffice. So we actually have 4x minus 5 equals 0. So if I move this over, it becomes positive. So I have a positive 5 here. If I divide everything through by 4, I will have 5/4. And so that would be my answer. Okay. So now moving on to the square root property. And so remember, before was our factoring property. Okay. So remember, in all of these things, we do want one side to be equal to 0 to see what's going on there. But with the square root property, what's really awesome about this is that if you have a perfect square, notice this perfect square here is just some expression u, that's a perfect square equals some number d. This means that you can take the square root of both sides. But when you do, remember you have the plus and then you have the minus there. So there's this familiar symbol where it's a plus minus. So remember, whenever you take the square root of both sides, you must put a plus and a minus between them. Okay, so this is what I'm going to do. So what I want to do always in first, when I start using the square root property, when I see that perfect square in there, and I don't see this middle term bx, I don't see it, then I can use the square root property, and it goes a lot quicker than the factoring. Unless y'all are like super fast at factoring, then it doesn't so much. But here, notice that here is my perfect square. So what I'm going to do is I'm going to solve for this perfect square first. And in doing that, I have to move this 1 over. So now I have this 3x squared equals, and that turns into a 48. So now I simply divide both sides by 3. And so I have x squared equals 16. Okay, you guys, so since this is a square, I want to get rid of that square by taking the square root of both sides. So that when I take the square root on both sides, I have the square root of x squared equals the square root of 16, and don't forget your plus or minus out in front. And so we have that square root cancels out with that square, leaving us with just x. Well, we know that square root of 16 is just 4, so we actually have plus or minus 4. So those are two solutions. So you could write it like this, or you could say that x equals a positive 4 or a negative 4. Okay. Notice that this is a list of solutions, and this is not a point. You do not put parentheses around it. So remember, with this one, you will want to solve for the x squared portion first, and then utilize the square root property. So let's write that somewhere. So solve for the square root, SQRT, square root, the square root first. Okay, let me erase this and put in the square first. Then use square root SQRT property. Okay, so this one's nice. Notice that this perfect square is already solved for. So at this point, I can just go ahead and take the square root of both sides. But remember that you have to have a plus or minus there. So the square root cancels with the square, leaving me with this x minus 3 equals plus or minus square root 36. Just so happens to be 6. So when I move this 3 on over to the other side, I have x equals positive 3 plus or minus 6. So this gives us two solutions still. So this gives us our 3 plus 6, and this gives us our 3 minus 6. So 3 plus 6 equals 9, 3 minus 6 equals negative 3. So here are our two solutions. Okay. So again, this is really nice. This is already solved for. So all we have to do now is once again take the square root of both sides. So plus or minus the square root of negative 7. And so now remember that that square root of a negative number is, you guessed it, it's I. It's that imaginary number. So the square root cancels out with this square. So you have x plus 2 equals plus or minus I times the square root of 7. You could write I on the other side, but please make sure that the I does not look like it's underneath the square root symbol. So our last step here is x equals negative 2, because we have to move that positive 2 from the left-hand side over to the right-hand side. And so we're finished here. There are no more calculations left. This is the most exact, most simplest form that we can actually get that into. Okay, so now our third and last way of solving quadratic equations is using this quadratic formula. And I know that everyone has seen this at some point before. you want to, there's actually a neat little YouTube video to where you can actually do a song and dance for the quadratic formula. But however, I will not do that for you because it would be horrifying. Anyways, let's go ahead and look at using this quadratic formula. I can say that the main thing with this is just getting the formula right and making sure that you're plugging things in properly. And what I mean by plugging things in, I mean go ahead and utilize parentheses, meaning that you're using your ideas of what you know about substitution. Okay, and note that this formula, this here, let me just do this. Note that this goes all the way over, right? It doesn't stop just when it reaches this square root symbol. It is all over this. So the whole entire numerator is your negative b, the plus or minus in that square root, okay? Not just the square root. So I want to make that very clear before we move on, because I've seen that so many times on tests and things like that, and it's just, you know, it's just one of those little things that a tiny error like that can cost you like 4 or 5 points on a test. So you don't want that to happen. So just write the formula down properly and then substitute in. And so at this point, all we have to do is know what our A is, our B is, and what our C is. So in this scenario, our A is 1, because there's that implied 1 there. Our B is equal to 8, and our C is equal to 12. So when we have this, we're just going to go ahead and write down this formula, but I'm going to put in my substitution. Wherever I see a letter, I'm going to use grouping symbols, okay? All divided by 2 times something. Okay, so now for all my B's, notice my B's. I've got that negative B, so I'm going to put in this 8 here and an 8 there. So that fills in all my B's. Notice my A's, I've got a 1 here and a 1 there, so that fills in all my A's, and so then my C left is going to be 12. Okay, so now that we have our grouping symbols in here, note that our 8 squared is going to be 64. This is going to be negative 8. So I have equal to negative 8 plus or minus the square root of 64 minus 48 all over 2. So 64 minus 48, getting on your calculator, equals 16. So I have x equals negative 8 plus or minus the square root of 16 all divided by 2. And so we know that this square root 16 is simply 4. So we have equals negative 8 plus or minus 4 all divided by 2. Now remember with this, you have 2 answers, okay? Let me go ahead and move this down just a tad bit so we can have a little bit more room. And so looking at this, we notice that we have x equals negative 8 plus 4 divided by 2. And we also have x equals negative 8 minus 4 divided by 2. So negative 8 plus 4 gives me negative 4 all divided by 2, and so that gives me negative 2. So there's one of my solutions. My next solution is I've got negative 8 minus 4 gives me negative 12 over 2. So negative 12 divided by 2 gives me negative 6. And so that's my other solution there. Okay. So remember what we did. All that we did was use the quadratic formula, write it down appropriately, and then use parentheses to fill in all of my letters, such as A, B, and C. So I had to know what those were in here. And then from there, I simplified what was underneath the radical, and then simplified the main expression into 2 numbers. Sometimes you will notice that you can have them as 2 numbers. Another way of noticing, if you have the square root of a negative number, of course there's going to be an I in there. So it might look more like an expression as opposed to a particular numerical real answer. Okay. So if I were to show you this, we have our A here equaling 1, our B equals 5, and our C equals 2. So x equals negative 5 plus minus square root 5 squared minus 4 times A times C all over my 2 times my A. So here I have negative 5 plus or minus the square root of 25 minus 8 all over 2. So 25 minus 8, that would give me 17. So I have negative, I don't know why I must put negative 15. Okay. Negative 5 plus or minus the square root of 17 all divided by 2. This is as far as we can go with this particular question. Okay, so we could say that x equals negative 5 plus the square root 17 over 2. You can also say negative 5 minus the square root 17. Okay, I just need to scroll back here. I don't know what just happened. I guess I moved some of the cursor. Okay, so I have negative 5 minus square root 17 over 2. So those are my two answers there. And because I have that square root 17, note that this is in the exact form. So notice I'm not using decimals or anything. It's exactly negative 5 minus the square root 17 over 2, and exactly negative 5 plus the square root 17 over 2. Okay, so here, if given the choice which method you would use, why would you use it? So let's try it. First of all, notice that there's no square. There's no perfect square there yet. We need to see if we can find this. So if there is a perfect square there, maybe we can use a square root property. Hopefully it'll just work out nicely for us. But we're not going to know really anything until we actually multiply this expression out. So let's just go ahead and multiply this expression out on the left-hand side. So I have 2x squared plus 2x minus 5x minus 5 equals 2. So now I can go ahead and combine those like terms. So I have 2x squared minus the 3x minus 5 equals 2. So remember, this is not in general form yet, so what I'm going to do is I'm going to take this 2 and move it over here to the other side. So I have 2x squared minus the 3x minus 7 equals 2. Whoops, equals 0. I moved the 2 over, so that would be 7. Okay. So we have this expression. So let's look at this. Okay, so we do have a perfect square, and it's this little x squared here. But notice we have a bx term. Okay, so we have a b there. So that means that we can't use the square root property because of that b there, that extra thing. So what we're going to do is we're going to look at maybe factoring. Factoring might help with this. So if we were to talk about the AC method, we would say, well, we've got 2 times our negative 7, which gives us negative 14. So when we have this negative 14 here, there are no factors of negative 14 that add together to give us negative 3. So we can't use the AC method. So factoring's out, square root properties out. So the only other method that we can use is the quadratic formula. So that's the third and the last one that we have learned. So we have our A equals 2, our B equals negative 3, and our C equals negative 7. So we have our x equaling negative, and that's of negative 3, plus or minus the square root. And I just see one is there, but I'll go ahead and erase that. Plus or minus the square root of negative 3 squared. So notice a -3 times -3 gives us a +9, minus 4 times our a, which is 2, times our -7, divided by 2 times a, which is 2. So I have 3 plus or minus square root 9, and then I have this 8 times -7, so all that gives me a +56. All divided by 4. So I have 3 plus or minus 9 plus 56 turns into 65, all over 4. So let's see if I can take the square root of 65. Nope, it just gives me simply 65. So here, just want you guys to know that yes, it does give me a square root 65, meaning that I can't simplify that anymore, but if I wanted the decimal for it, I can press that button and it turns into the decimal form. Okay, so as far for now, all we have is this being that solution. So note that first of all, in order to figure out which way to actually solve something like this is first get it into general form. So see how we got into general form and we're like, well, because of this -3, we can use the square root property. And then we were like, okay, well, let's look at factoring. Can we factor this? And it turns out that we can't because at a times c, there's no particular numbers that add together to be this -3, so factoring is out. So our only other option was to use a quadratic formula. And this is your option that will work every single time. But I do want you to know that you will have to be able to, A, use your quadratic formula, B, use the zero factor property, and C, use that the square root property as well. So you have to be able to use all three of these. Okay, so don't just always do it by the quadratic formula. So be very careful with that. Okay, on to the next slide. This is what your homework is going to look like. Okay, so note where it says how much separate answers is needed. Okay, so notice how it says only type repeated roots only once, meaning remember when we had that, oh, where was it? The -5 with that, or the +5/4. Here we are. See how we had 2 of these? We only wrote down one of those. So that's what we want to keep in mind when we're doing these things. Okay, so note here, it says to check by substitution or using a graphing utility and identifying the x-intercepts. Remember that when you have this equaling 0, basically you are finding the x-intercepts for this. The only thing is that, first of all, we're not graphing these yet, we're just simply solving these. So just to let you guys know that's coming up. However, this one knows it says solve the quadratic equation by the square root property. So remember, you're going to move this 6 over, divide by 2, and then take the square root of both sides. So all of these look exactly like what we've gone over in this particular video. Again, if you have any questions, let me know, or simply press the Ask Your Instructor button if you are doing these assignments. But I hope everyone's had a great time watching this and learned a lot. And as always, let me know if you have any other questions, and have a wonderful day.